Welcome to Unit 4.3, Standard Modules. This video provides a complete integration guide for MicroPython and 32 Spanish pesetas, focusing on building an IoT system that sends notifications via line. A complete IoT system involves integrating hardware, which collects raw data, with ESP32 processing using MicroPython logic and standard modules, and finally connecting to the cloud for notification via Wi-Fi and the Line API. Standard modules are pre-written Python files that include ready-to-use functions. A major advantage is that they come pre-installed with MicroPython, so no external installation like pip install is needed. There are two main import strategies. Import math imports the entire module, requiring you to reference the module name, for example math, SQRT 144. From math import py imports only a specific function or variable into the main namespace, allowing direct use like print py. The essential toolkit includes the math module for calculations, random for data randomization, time for time management such as time.sleep which uses seconds, and datetime for date and time functions. Hardware-specific modules are crucial for 32 Spanish pesetas. The machine module is the core for controlling hardware, I/O, and power. UTime and urandom are MicroPython's resource-optimized versions of standard modules. The watchdog timer, or WDT, is a safety mechanism. If the main loop freezes, the WDT will force a system reboot, preventing the board from hanging. You must use WDT feed periodically to reset the timer. The network module is the first step for communication, setting the ESP32 as a Wi-Fi client using the STA_IF mode. You need to activate the Wi-Fi chip and connect to the network using the SSID and password. This flowchart shows the robust Wi-Fi connection loop. While the connection is pending, the loop pauses for 1 second and, critically, feeds the watchdog timer to keep the board alive during network waiting. An API acts as a standard intermediary bridge connecting the 32 Spanish pesetas to the internet. The "Your Requests" module is the key standard library for sending HTTP requests to servers, like the Line platform. Sending data to Line Notify requires structuring an HTTP POST request. This involves the destination URL, the headers containing the authorization token, and the payload data, which is the message content. The main loop architecture is essential for reliable IoT operation. It follows a 4-step cycle. Check-in by feeding the watchdog, gathering data, logic and decision-making, and taking action, such as sending a notification. In this real-world smart agriculture scenario, the ESP32 measures simulated moisture data. If the moisture level drops below 40%, a line notification is triggered, instructing the user to water the plants. This video clarifies common MicroPython misconceptions. You use import instead of pip install, time.sleep 10 is 10 seconds, not milliseconds, and you must use HTTP POST for line notify, not get. The 3 pillars of a sustainable IoT system are code reusability through smart imports, connectivity via stable network and API connections, and reliability ensured by mechanisms like the watchdog timer.